7.5, the properties of logarithms. So YouTube has made it so that if you don't watch this video all the way through and pay close attention, then you won't be able to load the practice problem videos. Not really. They didn't do that. But you should watch this video, even though it's going to be just a bunch of proofs. And to get this section done, all you would really need to do is see some examples. But you should know why these things work. You should see a proof and be convinced that they work. The first property that we'll prove in just a minute is the product property. That's to say that if I'm taking the log base b, whatever base I want, of two things that are multiplied together, right? Let's put some parentheses there. If I'm taking log base b of this product of things, then I can break it up. I can expand it. What they call it in the books is expanding. Log base b of m plus the log base b of n. The second one is called the quotient property. If I take the log base b of this quotient of two things, I can expand them by saying the log base b of m minus the log base b of n. The last property that there's three properties in one formula. So this third property is called the power property. Okay, so if I'm taking the log base b of m to the n, if I'm taking the log base b of a power of another number to a power, then this guy here can come down out of the exponent and become the coefficient. Log base b of mn times log base b of m. It's the power property. It's product, and these names are taken from what you're taking the log of. You're taking the log of a product. You're taking the log of a quotient. You're taking the log of a power. Alright? The last one, I'll put a little dotted line, right? These would be called properties. This would be called the change of base formula. Change of base formula. If I'm looking at log, I'm going to use the same letters as they use in the book, just for continuity. And it was already there, apparently. Okay, so log base c of a. Okay. This is very useful when we want to put a log that we are not sure of into our calculators. If I had log base 5 of 13, I don't know the power of 5 that gives me 13 offhand. I would like to be able to use my calculator to calculate it, and we can do that. We just need to use the change of base formula. Remember that our calculators cannot do log base 5. They can do log base 10 and log base e, the common log and the natural log. So what I do is I'll just pick another log of a different base than c, and I will say I'll use log base 10. Right? Any base will do, but for this example I'll use log base, actually for the formula let's just say any other base of a, log of any other base of a over the log of any other base of c. So in particular we could use log base 10 of a over log base 10 of c, or we could use the natural log of a over the natural log of c. If our calculator could do any other base, we could choose to use those bases, but these two bases will do. Either way you want to go, if you want to find log base 5 of 3, then you take the log base 10 of 3 over the log base 10 of 5, or the natural log of 3 over the natural log of 5. Okay, so those are the properties, and what we're going to do now is prove those properties. First, the product property. We're going to prove that log base b of m times n, remember that you're taking the base, or the log of all of that, is equal to the log base b of m plus the log base b of of n. Okay. So let's see. I could take b and raise it to some power, let's call it x, and I could get m. You know, so long as m is not negative, of course, but that wouldn't make any sense anyway. So whatever m is, I could raise b to some power and get m. If b were 5 and m were, 0.3, I could raise b to some power and get 0.3. Whatever it is, I can raise b to some power and get m. So we're just going to establish that. Then we'll take b to the y and say, well, b to some power y, I can make that be equal to n. Okay, so these equations would totally make sense as long as m and n are positive numbers. All right. So let's see. Well, you see I have m times n, right? So I'm going to multiply m times n over here. M times n. Well, what's that equal to? Well, this is equal to m, and this is equal to n, so I can multiply these two guys together. B to the x times b to the y. Okay. Well, now let's combine these together because of the same base. That's b to the, what do I do with these powers? I add them. So x plus y equals mn. And now let's write this in log form, right? So log base b of m times n is equal to x plus y. And look at what we have here. We have the left side of the equation, log base b of m times n equals x plus y. Now, what are x and y? Let's find out. Let's go back up to here. Here's x. Let's find out what x is by writing this in log form. This would be log base b of m. That's x. And likewise, log base b of n, well, that's y. So this x plus y is the same as log base b of m plus log base b of n. Okay, so, and we've proved it. So this thing up here is equal to this thing here, and that's the thing we were trying to show. That's the product property. And hopefully you can see that in words, if you can follow this. What's the power of b that gives me m times n? Well, it's something, right? It's equal to something. The power of b that gives me m times n, what's that power? Well, whatever that power it is the power of b that gives me m plus the power of b that gives me n, right? So that is, in words, kind of what this property is saying, and it makes sense, too, in words. So there's the proof of the product property. Very similar to that proof is the proof of the quotient property. Equals log base b of m minus log base b of n. All right. So b to the x equals m, b to the y equals n. So here's what we want to talk about, m over n. So m over n, well, this is also m. This is also n. So these are equivalent. Okay, now let's combine these together. What do I do with the exponents when I'm dividing and they have the same base? I subtract the exponents. Let's write this in log form. So in log form, log base b of m over n is equal to x minus y. Well, what are x and y? Well, let's write this in log form. Log base b of m is equal to x, and log base b of n is equal to y. So I'll substitute this for x and this for y. Log base b of of m minus log base b of n. Okay, and in words, what's the power of b that gives me m divided by n? Well, it's the power of b that gives me m minus the power of b that gives me n. It's kind of displayed in this step right here, right? Here's b to the power of x gives me m, and b to the power of y gives me n. So the power of b that gives me m minus the power of b that gives me n is the power that gives me m over n. I hope that made some sense to 0.3 of you. Now the power property, log base b of m to the n is equal to n times log base b of m. Now, what I'm about to do, this proof method, I don't particularly love, because what I'm going to do is use a previous thing that I just proved to prove this. It's completely sound and legal and everything. I like proofs to stand on their own, but I think it's easier to see and understand if we just use a previous property. And we're going to use the product property. Okay, so let's look at the left side of the equation. Log base b of m to the n. Okay, so now I'm going to write m to the n in a different way. What does m to the n mean? It means m times itself n times, right? I'm going to take m and I'm going to multiply it by m and I'm going to multiply it by m and so on. How many times am I going to multiply m by itself? I'm going to multiply it by itself 1, 2, 3, 4. I don't know how big n is, so I'm just going to put some dots in here. All the way up till n. Right? I'm counting, these little numbers are just a way of counting all of the m's. I'm counting the first m that I'm multiplying by the second, the third, the fourth, all the way up to the nth. Whether n is 5 or 75 or 155, I'm just counting them and I'm putting an ellipsis in there to stand in place of all of the m's between the fourth one and the nth one. Okay? So the thing about this is a product of a bunch of things. And if you remember from the product property, let's pull up this piece of paper here. Product property says if I have a product of things inside the parentheses that I'm taking the log of, well, I can just take the log of them separately and add them together. Right? So that means that I can rewrite all this as log base b of m1 plus log base b of m2 plus log base b of m3 and so on, plus log base b of m sub n. So I'm adding up all of these log base b's of m. Remember, these m's are the exact same thing. They're all 3 or they're all 7. They're all the same number because I'm multiplying it by itself n times. So now I'm adding all of these logs together n times. Well, what's the same thing as saying add it up n times, right? Like if I did x plus x plus x. I've done that 3 times. That means I have 3 times x. Right? If I have y plus y plus y plus y, well, there's 4 of them. That's the same as saying 4y. It's much faster to say that. Well, however many of them I have, it's 3 times that thing, right? So the thing that I have is log base b of m, and I have 1 of them, 2 of them, 3 of them, all the way up till I have n of them. Right? So I have n times log base b of m. Right? And that's what I was trying to show. I rewrote this part of the equation. I invoked the product property to add them all up. And then I said, well, if I add up n of them, then I have n times that thing. Right? So there you go. There's a quick proof using a previous property that we already used. And now for the formula, the change of base formula. I am going to take this last proof into the next video, so I will see you there.